Ron speaking. Me and the cat in the basement. I liked the Imhotep's circuit, Imhotep auto relay energizer, and I have gone and made it complicated just so I can play with electromagnetic flyback in more detail. So what I have done is I have an auto relay over here. I bought a whole bag of them, and I am energizing the coil from a battery pack, my standard AA battery pack. It's only coming in at 10 volts right now, and I am using a 555 timer integrated circuit with some other things attached to it to alter frequency and duty cycle to turn this transistor on and off. So altogether, basically, this is the Imhotep relay charger circuit made very complicated. What I'm doing is playing with the frequency and duty cycle of EMF production. Excuse me, Katie. Pardon me while I play with the camera. It's got too much stuff in there, I can't see it. So basically, I have the schematic diagram, and the 555 timer is hitting the base of a transistor, which is letting a battery charge or not charge this coil. Now, what I want to experiment with is what frequency and duty cycle create the best electromagnetic flyback, and also how many coils can be put in parallel or series to augment the effect. And I should actually have a transformer between the coil and the load, but I try to keep these things simple so I know what I'm doing. So the deal is, I'm using a light bulb right now for my load, and if I just turn the circuit on, oh, I got the cat under my feet, under my rug here. You can see that the relay is buzzing away, creating electromagnetic flyback into the load, the light bulb. And so this allows me to play with frequency and duty cycle. You can hear you can hear and see this. I use a light bulb like a oscilloscope. This is a dimmable bulb, so any voltage will set it off. And I could try higher frequencies, wider duty cycles, until I find out what's best. Now the flapper running inside the relay has absolutely no effect. It's not connected at all. I am only using the coil. But it also occurs to me that when I was playing with this, to see the most efficient electromagnetic flyback, that it would also be a great control mechanism for a giant coil and battery pair like I have on my Bedini schoolgirl motor. So if I took the relay contacts I'm not using, the flapper going up and down that just makes or breaks electrical contact, I would have something more like this, just a giant 30 amp switch connected to a battery or a series of batteries going to a gigantic coil through a rectifier and a transformer to fire up a huge load, such as the coil I have on that big bad boy over here. That coil fires off at 292 volts at over half an amp, so that's 150 watts of power. So if I use this timing mechanism on the Bedini to bypass the wheel and the magnets, I'm thinking I have something I can play with, something I can that might be able to produce some real power, and to be able to measure once and for all how much energy it takes to run this equipment and how much energy is produced by electromagnetic flyback. Is it worth it? I think it is. I think the rest of us know it is, but I think it's time we prove it. So I have a series of things I'm going to be doing in the future. This is just the setup. I think I want to make my my 555 timer. I think I want to put that baby in a box and use some potentiometers instead of the tiny little dials there, and basically start taking some readings. How much am I using? How much am I producing? Is this, I mean, let's think of it this way also. You don't have to use batteries. I could actually be plugging that into a wall socket with a wall wart, a 12-volt power supply, and using a kilowatt meter, such as this one over here. I could be measuring, up here we are, the old kilowatt. I could be measuring how much I'm pulling out of my wall, how much I'm paying, and how much energy I'm producing. How much money would I save at 8 cents a kilowatt? Is it worth it? I'll let you know in the future. In the meantime, I'm horsing around. I'm playing with this stuff. Oh, there's one more resource I'd like to show you. If you're interested in 555 timer chips, daycounter.com has a calculators page or section in which various circuits are displayed, and they have calculators you can use. Now, the Daycounter Inc. Engineering. And what they have for you on the 555 timer page is a schematic diagram of the chip, where things go, what pin does what. It has the formulas, the equations that you'd be interested in to figure this out, and they also have a handy calculator. So if you wanted to figure out, well, I want 2 kilohertz at 80% duty rate, what components do I need? Well, you need a 4 kilo ohm, 1 kilo ohm resistor, and a 0.1 microfarad capacitor. So this page is really great if you're into 555 timers.